I was excited to be a part of the dream theme, and then I found out I'm leading off the nightmare section of it. And certainly, there are things about the climate crisis that qualify. And I have some bad news, but I have a lot more good news. I'm gonna propose 3 questions. And the answer to the first one necessarily involves a little bad news, but hang on, because the answers to the second and third questions really are very positive. So the first question is, do we really have change? And of course, the Apollo mission, among other things, changed. The environmental movement really launched the modern environmental movement 18 months after the Earthrise pictures of first seen on Earth. The first Earth Day was organized, and we learned a lot about ourselves looking back at our planet from space. And one of the things that we learned confirmed what the scientists have long told us. One of the most essential facts about the climate crisis has to do with the sky. As this picture illustrates, the sky is not the vast and limitless expanse that appears when you look up from the ground. It is a very thin shell of atmosphere surrounding the planet. That right now is the open source for our industrial civilization exists. Finally organized, we are spewing 110 million tons of heat-trapping global warming pollution into it every 24 hours free of charge. Go ahead. And there are many sources of the greenhouse gases. I'm certainly not gonna go through them all. I'm gonna focus on the main one. But agriculture is involved, diet is involved, population is involved, management of forests, transportation of the oceans, the melting of the permafrost. But I'm gonna focus on the heart of the problem, which is the fact that we still rely on direct carbon-based fuels for 85% of all the energy that our world burns every year. And you can see from this image that after World War II, the emission rates started really accelerating. And the accumulated amount of man-made global warming pollution that is up in the atmosphere now traps as much extra heat energy as would be released by 400,000 Hiroshima-class atomic bombs exploding every 24 hours, 365 days a year. Fact-checked over and over again, conservative is the truth. Now it's a big planet, but that is a lot of energy, particularly when you multiply 400,000 times per day. And all that extra heat energy is heating up the atmosphere of the whole Earth system. Let's look at the atmosphere. This is a depiction of what we used to think of as the normal distribution of temperatures. The white represents normal temperature days, 1951 to 1980 upward chosen. The blue are cooler than average days. The red are warmer than average days. But the entire curve has moved to the right in the 1980s. You will see in the lower right-hand corner the appearance of statistically significant numbers of extremely hot days. In the 90s, the curve shifted further, and in the last 10 years, you see extremely hot days are now more numerous than the cooler than average days. In fact, they are 150 times more common on the surface of the Earth than they were just 30 years ago. So we are having record-breaking temperatures, 14 of the 15 of the hottest years ever measured within 2 months. Have been in this young century. The hottest of all was last year. Last month was the 371st month in a row, warmer than the 20th century average. And for the first time, not only the warmest January, but for the first time, it was more than 2 degrees Fahrenheit warmer than the average. These higher temperatures are having an effect on animals, plants, people, ecosystems. But on a global basis, 93% of all the extra heat energy is trapped in the ocean. And the scientists can measure the heat build up much more precisely now at all depths deep mid-ocean. The first few hundred meters and this too is accelerating. It goes back more than a century, and more than half of the increase has been in the last 19 years. This has consequences. The first order of consequence, the ocean-based storms get stronger. Super Typhoon Haiyan went over areas of the Pacific 5.5 degrees Fahrenheit warmer than normal before it slammed into Tacloban as the most destructive storm ever to make landfall. Poor Francis, who has made such a difference to this whole issue, visited Tacloban right after that. Superstorm Sandy went over areas of the Atlantic 9 degrees warmer than normal before slamming into New York and New Jersey. The second order of consequences are affecting all of us right now. The warmer oceans are evaporating much more water vapor into the skies. Average humidity worldwide has gone up 4%, and it creates these atmospheric rivers. The Brazilian scientists call them flying rivers. They funnel all of that extra water vapor over the land, where storm conditions trigger these massive record-breaking downpours. This is from Montana. Take a look at this storm last August. It moves over Tucson, Arizona. It literally splashes off the city. These downpours are really unusual. Last July in Houston, Texas, it rained for 2 days, 162 billion gallons. That represents more than 2 days of the full flow of Niagara Falls in the middle of the city, which was of course paralyzed. These record downpours are creating historic floods and mudslides. This one is from Chile last year. And you'll see that warehouse going by. These are oil tankers, cars going by. This is from Spain last September. Could call this the running of the cars and trucks, I guess. Every night on the TV news now is like a nature hike through the book of Revelation. The insurance industry has certainly noticed. The losses have been mounting up. They're not under any illusions about what's happening, and the causality requires a moment of discussion. We're used to thinking of linear cause and linear effect, one cause, one effect. This is systemic causation. As the great Kevin Trenberth says, all storms are different now. There's so much extra energy in the atmosphere. There's so much extra water vapor. Every storm is different now. So the same extra heat pulls the soil moisture out of the ground and causes these deeper, longer, more pervasive droughts. And many of them are underway right now. It dries out the vegetation and causes more fires. The western part of North America, there's certainly been evidence that a lot of them are more lightning. As the heat energy builds up, there's a considerable amount of additional lightning also. These climate-related disasters also have geopolitical consequences and create instability. The climate-related historic drought that started in Syria in 2006 destroyed 60% of the farms in Syria, killed 80% of the livestock, and drove 1.5 million climate refugees into the cities of Syria, where they collided with another 1.5 million refugees from the Iraq War, and along with other factors that opened the gates of hell that people are trying to close now. The U.S. Defense Department has long warned of consequences from the climate crisis, including refugees, food and water shortages, and pandemic diseases. Right now we are seeing microbial diseases. Microbial diseases from the tropics spread to the higher latitudes. The transportation revolution has had a lot to do with this, but the changing conditions change the latitudes and the areas where these microbial diseases can become endemic and change the range of the vectors like mosquitoes and ticks that carry them. The Zika epidemic now. We are better positioned in North America because it's still a little too cool and we have a better public health system. But when women in some regions of South and Central America are advised not to get pregnant for 2 years, that's something new that ought to get our attention. The Lancet, one of the 2 greatest medical journals in the world, last summer labeled this a medical emergency now, and there are many factors because of it. This is also connected to the extinction crisis. We are in danger of losing 50% of all the living species on Earth by the end of this century, and already land-based plants and animals are now moving towards the poles at an average rate of 15 feet per day. Speaking of the North Pole, last December 29th, the same storm that caused historic flooding in the American Midwest raised temperatures at the North Pole 50 degrees Fahrenheit warmer than normal, causing the thawing of the North Pole in the middle of the long, dark winter polar night. And when the land-based ice of the Arctic melts, it raises sea level. Paul Nichols' beautiful photograph from Svalbard illustrates this as more dangerous coming off Greenland, and particularly Antarctica. The 10 larger risk cities for sea level rise by population are mostly in South and Southeast Asia. When you measure it by assets at risk, number 1 is Miami, $3.5 trillion at risk. Number 3, New York and Newark. I was in Miami last fall during the supermoon, one of the highest high tide days, and there were fish from the ocean swimming in some of the streets of Miami Beach and Fort Lauderdale and Delray. And this happens regularly during the highest tides now. Now with rain, they call it sunny day flooding. It comes up through the storm source, and the mayor of Miami speaks for many when he says it is a long past time this can be viewed through a partisan lens. This is a crisis that's getting worse day by day. We have to move beyond partisanship. And I want to take a moment to honor these House Republicans who had the courage last fall to step out and take a political risk by telling the truth about the climate crisis. So, the cost of the climate crisis is mounting up. There are many of these aspects I haven't even mentioned. It's an enormous burden. I mentioned just one more because the World Economic Forum last month in Davos, after their annual survey of 750 economists, said the climate crisis is now the number 1 risk. After their annual survey of 750 economists said the climate crisis is now the number one risk to the global economy. So you get central bankers like Mark Carney, the head of the UK central bank, saying the vast majority of the carbon reserves are unvulnerable subprime carbon. I'm not gonna remind you what happened with subprime mortgages, but it's the same thing. If you look at all of the carbon fuels that were burned since the beginning of the Industrial Revolution, this is the quantity burned in the last 16 years. Here are all the ones that are proven and left on the books. $28 trillion. The International Energy Agency says only this amount can be burned. So the rest, $22 trillion unburnable risk to the global economy. That's why the investment movement makes practical sense, and it's not just a moral imperative. So the answer to the first question, must we change, is yes, we have to change. Second question, can we change? This is the exciting news. The best projections in the world 16 years ago were that by 2010, the world would be able to install 30 gigawatts of wind capacity. We beat that mark by 14.5 times over. We see an exponential curve for wind installations now. We see the cost coming down dramatically. Some countries, take Germany, industrial powerhouse, with a climate not that different from Vancouver's, by the way. One day last December got 81% of all its energy from renewable resources, mainly solar and wind. A lot of countries are getting more than half on an average basis. A lot of countries are getting more than half on an average basis. A lot of countries are getting more than half on an average basis. More good news, energy storage from batteries particularly is now beginning to take off because the cost has been coming down very dramatically to solve the intermittency problem. With solar, the news is even more exciting. The best projections 14 years ago were what we would install 1 gigawatt per year by 2010. When 2010 came around, we beat that mark by 17 times over. Last year, we beat it by 58 times over. This year, we are on track to beat it 68 times over. We are gonna win this. We are gonna prevail. We are going to prevail. The exponential curve on solar is even steeper and more dramatic. When I came to this stage 10 years ago, this is where it was. We have seen a revolutionary breakthrough in the emergence of these exponential curves. And the cost has come down 10% per year for 30 years and is continuing to come down. Now the business community has certainly noticed this because it's crossing the great parity point. Cheaper solar penetration rates are beginning to rise. Great parity is understood as that line, that threshold below which renewable electricity is cheaper than electricity from burning fossil fuels. That threshold is a little bit like the difference between 32 degrees Fahrenheit and 33 degrees Fahrenheit, or 0 and 1 Celsius. The difference of more than 1 degree is the difference between ice and water, and it's the difference between markets that are frozen up and liquid flows of capital into new opportunities for investment. This is the biggest new business opportunity in the history of the world, and 2/3 of it is in the private sector. We are seeing an explosion of new investment starting in 2010. Investments globally in renewable electricity generation surpassed fossils. The gap has been growing ever since. The projections for the future are even more dramatic. Even though fossil energy is now still subsidized at a rate 40 times larger than renewables, and by the way, if you add the projections for nuclear on here, particularly if you assume that the work many are doing to try to break through to safer and more acceptable, more affordable forms of nuclear, this could change even more dramatically. So is there any precedent for such a rapid adoption of a new technology? Well, there are many, but let's look at cell phones. In 1980, AT&T, then Marvell, commissioned McKinsey to do a global market survey of those clunky new mobile phones that appeared then. How many can it sell by the year 2000? They asked. McKinsey came back and said 900,000. And sure enough, when the year 2000 arrived, in the first 3 days, they did sell 900,000 in the first 3 days.